Good morning, everybody, and welcome to this course on an intro to procedural content generation for the Unreal Games Fellowship 2024. Okay, so what are we going to cover in this course? Well, we're going to spend, I say about half an hour, but it's usually less, of going over some of the concepts and the basics of this. Going to talk about where you can use it, use cases, some of the limitations, and installation. Then, and this will be the majority of the class, we are going to do an exercise where we'll populate a world. Unfortunately, it's not easy to break this down into smaller chunks. But we will go over it and learn stuff as we go. So yeah, it is going to be a bit of an exercise class. You can follow along or you can watch. It's up to you. I'm going to presume that people are following along. Then finally, we are going to go over a bunch of examples. Just talk about populating at runtime. We don't actually do that. I don't know if Lucas, if you could chat about populating at runtime at the end. Have you played with that yet? Or
I
Andrew?
haven't. That's one thing I've not touched.
Yeah, that's something that we need a course on.
Yeah.
Yeah. Okay, so installation. There are two plugins which are that I would always turn on whenever I'm using PCG. And the first one is a necessity, which is procedural content generation framework. I don't even know if this is turned on by default these days, but that is there. And the second one is procedural content generation framework geometry script interops. This is so you can work with, rather than just working with static meshes or actors or something like that, if you want to work with the geometry of meshes, especially if you want to scatter things on certain vertices or elements like that, this is where PCG interconnects with geometry script. And if you haven't encountered geometry script within Unreal Engine, what it is it is our modeling tool base language. So you can come in and you can change, alter, create meshes. So this is where the two overlap. This is how they talk to each other. So I recommend you keep it on because you'll see that some of the nodes that we use will only appear if you have this on. Okay, let's talk about concepts. Now, there are two important terms that I want you guys to, I want you to understand to make sure that this makes basic sense. The first one is, what these two terms are referring to is when you're creating procedural, when you're using PCG, you have your endpoint, which is what the world looks like, which is usually scattered meshes or meshes scattered in some kind of logic. Now, these are the elements that you will use to get there. So these are your main. So the first one is points. Now, these are locations in 3D space that are generated by the PCG graph and often used to spawn meshes. Points contain information about the transform, bounds, color, density, steepness, seeds, and they can be assigned user-defined attributes. So points are working values. And as you can see here, all of these little squares, they are a visual representation of points. So they are, this is, what you'll see is we have a process where we go from left to right, and the points will change values with every different node that we put in. We'll do different calculations, and each different node will have a set of points, which is assigned to it with the information on it that is needed. And the second thing is the points density. Now, this is a value used by a variety of graph nodes, and this is represented in the debug view as a gradient on each point. A density of 0 is black and a density of 1 is white, often used for filtering. So we talk here about points where we have lots and lots of information on each of the points. Density is an easily visualizable value. So you can see here these points are different shades of gray. It's an easily visualizable value which we will pass different parameters into so that we can use them easily with the other nodes. So say, for example, you have a steepness value or something within a node, within a point. Now, we don't have a load of nodes which will change steepness. So we don't have filter by steepness. Actually, there might be some in there, but what you would usually do is pass the steepness out to the density and then use that as a means of filtering or doing other things too. So density we're going to talk about and use quite a bit in here, but it's just our working value. Okay. Would you say that's accurate, Lucas?
Yeah, sounds good to me.
Cool.
Yeah.
Okay, so that is not half an hour worth of theory, but that is all the theory that we need until we can jump into the project. So, as per usual with any of these, we have, well, as of any of my projects, every step we're doing is described page by page as we're going. So if you miss something, you can always jump back to this in order to sort of follow along. But as I will be following along with it as we're going. So let's jump into the project. Now, the first thing is, if you've got the teacher's aid up, you'll be able to go to right to the beginning, and we'll start off with this small landscape here. If you don't have this up, you can either find it within teaching aid, or you can just navigate around. It's the plot on furthest on the left. And okay, so this is our beautiful landscape. Now, the first thing that we're going to want to do when we're working with a PCG is to add a PCG volume into the world. Now, to do this, if we just come up to add, hopefully everyone's here, and search for PCG, you'll see that we have an option for a PCG volume. I'm then going to drag this into the world. And I want to increase this in size. So in order to increase this in size, what I'm going to do is I'm going to find the brush settings. Now, if you type in brush, you might not see, oh, here we go, brush settings here. So I'm going to change these brush settings to 10,000 by 10,000 by 4,000. So that would give us a nice box which will cover a section of the landscape. You might want to move it around to make sure that it covers something appropriate. So again, we're adding a PCG volume to the screen, and we're changing the brush settings just so that it covers a bunch of the landscape. Right, let's break this down and jump back into the level. So the next thing, I'm gonna fire up my content directory and dock it into the layout so that we've got it here. And you'll see that we have a folder for exercise. We also have a folder for completed. So this will have everything already in here done. So if at any point you get stuck and you're like, why isn't mine working? You'll find the finished version here that will allow us to open that up. But we're going to build this from scratch. And I'm going to build this in the exercise folder. This comes with a number of assets which we are going to use. Now, so the first thing we need to do is we need to create our graph, because we have our volume, and that's the area which it's going to be created in the world. And then we need a graph to go with it. So with this selected, under the PCG, now we see that a PCG component here under settings, where's the graph? Okay, so this is quite deep. So I'm going to show where this is. So I've selected the PCG volume. You can probably just type graph in here. Like, oh, maybe you can if you spell it correctly. Yeah, you type graph in, you'll find that it's under PCG components, setting, graph instance. Now, I am going to create a new one. So under this, I'm going to come up and I'm going to select PCG graph. I'm going to select the examples, and I'm going to call this my PCG graph. I try and begin stuff with my quite a lot so that I can easily find it in a project that's got a lot of other stuff in there. So now I have my PCG graph. The other option is you could create a new asset and set it up there. I just find this a little bit quicker. Okay, so we have my PCG graph. Dropped in examples, not exercise, so I'll just move it there. Right, now I'm going to open this up. And we get something that looks like this. So again, I'm going to reiterate, I've added a PCG volume to the level. This is going to tell it where we're going to procedurally generate content. And then in this PCG volume, I have found graph, which is under PCG component settings, graph instance. And I've created a new asset, called it my PCG graph, and I've saved it within the exercise box. Okay, so then I just open this up and it's given me a screen which looks like this. Okay, so all we have is this blank thing with two nodes for an input and an out. Now, let's go through the elements we have. Now, you should be pretty used to these kind of interfaces by this point. Right-hand mouse button is going to allow us to drag around. You're going to notice that we don't automatically have an output and input pin on these, but you can grab one. On the left-hand side here, we have a node palette where we can just grab stuff in. However, we can also right-hand click just to search for stuff, and that's what I'm going to be doing most of the time. We also have an attribute element down the bottom here, and I'm going to show this off after we've jumped into creating some stuff, because we've got no data to look at this point. Now, on the right-hand side, we have our details panel again. So this is contextual, depending on what you have selected. And up the top, we have a couple more options. We have the save, browse to, the standard. We also have the find, which is standard. But we have force regen and pause regen. Now, this is going to give us some control over when it goes away and regens. Now, if your PCG gets big, it might take a while to regen. Now, generally speaking, these are really fast, especially when I reference Houdini quite a lot, and if you're not used to Houdini or haven't played with it, it is a great tool, an advanced tool for procedural creation, animation, generation. You can do pretty much anything in it, but it always works under a framework of something being procedural. That you have an input at the top in Houdini, and then you have a whole load of nodes and an output at the bottom. Now, now this works in a very similar way, but you've got an input on the left and an output on the right, and we're going to be adding in a whole load of different nodes that you can switch on and off, which I'll demonstrate, a bit like Niagara when we worked on the other one. Yeah, to get from the left to the right. Now, pause regen means that it will pause automatic regen. So you'll have to manually tell it to regenerate when you want to. Force regen can flush the cache and will force that the node is going to be regenerated. Okay, so let's create some, because without creating anything, we cannot really get a feel of how this works. So I'm going to do a drop down on the input on the left-hand side here. And yeah, we no longer have that. Actually, I'm going to search for landscape. Get landscape data. I think this is the change.
Yeah.
Yeah, and this is yeah, so this is a little bit different from the settings. The input and the output pin are less important these days because we aren't necessarily going to have to start with them. What we can do is we can pull in nodes as a starting point. Now, the output pin is only really important if you are going to be nesting PCGs into other PCGs. So you might write a PCG which generates I don't know, if you've watched like a rock formation with trees stuck to it and stuff like that, complicated. You might create that and you might add that into another PCG. So this is when the input and the output nodes are going to be important, because when you drag that node in, you probably want to have some input settings, and then you'll want to have output settings coming out the other end. So because we are not nesting this PCG into another PCG graph, these are not so important to us. And if we look at the notes, this needs updating. It was previously set so that we can it was previously set so that you got the data from the input pin. This is now slightly different. I might need Lucas's help at some point in this. So okay, or Andrew. Okay, so let's have a quick look at these surface sampler. Now, what's interesting is we now have a node, and if I was to jump into this, we have a number of settings that go with this node. Now, if I was to push D, so I'm going to go over hotkeys, and D is probably the first one. And with this selected, you can push D on and off, and this gives us debug. And now if I jump into the level, you should see that we have the points that we were talking about. So you can see that we've now got, we now have a bunch of different cubes that are scattered across our landscape. Now, each of these cubes have a different color on them, a different set of gray. This is the density that we were talking about. So, so this one will be something like 0.8, and this one would be like 0.1 or something. So they are randomly assigned values of density. Now, this is our starting point. So that is, so our first hotkey that you would need to know is D, because when we have like 20 of these, you're only really going to want to be able to see what the points are doing at a certain point down the procedural line. Now, the next thing, so the next one that's in here, let me just grab them up. The next one is A. What A will do is, if you push A, is it's going to inspect. Now, this is where at the bottom here, and okay, this is the bit that always throws me. Force region, no data available, surface sample. We should have data.
You just select the instance in the bottom left.
Ah,
And then you do the drop down and then select, yeah. So
okay.
each instance will have its own attributes.
Thank you. Okay, so that's the bit that always gets me. So A is going to allow us to view the inspect. So this will allow us to view the data that is within this node. So you can see here we've got a whole load of different default categories of data. So we've got steepness, density, a whole load of different elements here. And we got the seed. And so that is our starting point. So on the left-hand side, you have to select. So if you've got 50 instances, you can go between them. But that's going to be for this node. And again, this is A. The other thing that I can do is I can right-hand click and I can look at inspect here. So, and the final hotkey is E. And what this will do is this will enable or disable a node. And this is really useful because when you've got 10, much like in Niagara, where we were turning on and off modules so that we could see the effect that it has on the effect that it has on the end effect, we can do the same within PCG. So E is going to enable or disable. A is going to turn inspect on and off. And D is going to turn debug on and off. And debug is our ability to see the cubes. So those are our three major hotkeys. So we've got A, D, and E. Okay, so now if we look at what the data we've got here is, the first thing we're doing is we're getting the landscape data. So this is going to go through and it's going to get us the data from the landscape. We've got a number of other details that we can get in here to sort of reduce the data output, I believe. But we have a surface sampler. And so that is going to sample the surface. And we have a number of samplers. So you can see under samplers, we can sample volumes, surface, splines, meshes. So we have a number of different ways to get starting point data into our PCG. But we are using the surface. And we'll use the surface, I think, for the majority of this. So we've sampled the surface. Now let's play around with how we've sampled it. So with the surface sampler selected, we have a number of different objects here, options. And I think this is worth looking at. So I'm going to drag this out because it would be nice to be able to see what we're doing. So I'm going to just. So I'm bringing up the surface sampler here. And I'm just moving stuff around so you can see all of it on one screen at this point. So at the moment, we have samples like this. Now, I've got the ability for determinism. think under the landscape itself, they moved. Oh no, it might be. Uh, is there a Lucas? Where's the node to make it not stuck? To make it unbound, basically. Oh yeah, here it is, unbounded. So the first thing we have is unbounded. So the question is are you limited to the square that you've made? So that's our first turn on or off. As you can see, we don't have to be limited to that. It will just grab the landscape and get everything that's on the landscape. Now we have looseness. If I was to change this to 0, you'll see that we start getting a very high sort of, they are very, very consistent. They're all snapping to a certain point. As I move up looseness to 1, they will be more randomly distributed. We've got points per square meter. At the moment we have 0.1, but if I made it 1 and I made the looseness 0, we will get this checkered pattern, which will allow us to I often use it in order on a big scale to create, well, I'll demonstrate it later, but sort of city blocks, something that's going to be a more consistent. And we have, I'm going to toast that back to 1. We have the point extents. So if I was to change this to 300, you can see that I basically scaled up these points so that they are a lot wider. So, and we're going to play around with these because we're going to do a number of different samplings. So our first one that we're looking at doing is we're looking at making trees. So in order to make trees, I'm going to go bound just so that we can see the edge of it okay. And the thing about trees is this would be too dense. So I am going to change this to 0.02. So now we have a bit of a better scattering. And I won't change the point extents. Looseness 1, seed, we don't need to worry about. It will generate one of them each time. But that is our, so those are just the settings we want on the surface sampler. Okay, so I don't think I can continue with this like that, so I'm going to jump back into here. So the next thing I'm going to want to do is add some meshes. So I'm going to drag off of the out pin and I'm going to type in static mesh spawner. And this node is quite straightforward. Or what it will do is it will spawn a static mesh. So the main thing that's important when we're looking at the spawning is the mesh entities. So the mesh selector section, I'm going to want to add an entry in. And under the descriptor, I'm going to add in, I'm going to search for my tree. You can see that we have my tree. I'm also going to add a second one in. So add a second one in, and this time I'm going to change the descriptor to my bush. Okay. If I want to make this less confusing, sometimes I just add 2 elements in and then I will search for static mesh because that will give us a lot. That will filter down to give us a considerably cleaner setup. So in mesh entries, actually, if I just type in mesh, that's probably the best one. So under mesh entries, oh no, first static. I'm adding 2 entries in, and one of them is going to be for my tree, and one of them is going to be for my bush. Okay, so next up, let's see what this looks like. Hey, oh, we have a forest. So I'm going to turn off the, I'm going to turn off the debug on this one. Jump back into the level, and we have a forest. Now, I'm going to look at the thing, and there is a number of problems with this forest. For example, our trees are sticking out the sides where it's quite steep, sticking out at very odd angles. The trees are very similar. And the bushes are all right. So we got a rather unnatural looking forest at this point. So let's fix some of these. Let's fix some of these problems. Now, the first thing is, come on. Okay, so the first thing is what I want to do is I'm going to change the density and weight. So I'm jumping back into here. What I'm going to do is under my static mesh spawner, at the moment, if I type in weight at the top, you'll see that my tree and my bush, they both have a weight value under it. And this isn't great because they're both the same amount. And I want more bushes than I want trees. So I'm going to increase the bush to 5. Now, if I look at the world, I've got very few trees. I want more trees. So let's go back to the surface sampler, and we'll change this up to, make this 0.1. Save. Yeah, 0.1's a bit high. I'm going to make it 0.6. Okay, I'm relatively happy with that. We got slightly more bushes, and we're okay with trees. Now we still got the trees sticking out the side of mountains problem here, but I'll just take a pause for a second and see if anyone is majorly stuck. How's it looking in chat? People keeping up? Is it good?
Yeah, pretty smooth. There's no big questions right now.
Okay, fantastic. All right, in that case, I'll keep going. Do tell us if we're going too fast or too slow. Now, the next thing that I'm going to do, I want to make this look a little bit more natural. So I'm going to use a transform node. Now I'm going to drag off of here, and I'm going to type in transform. I'm looking for transform points, and that will be at the bottom here. So what this node is going to do is it's going to allow me the ability to make alterations to so the meshes are spawned on the points, but I can transform the points using this. So what I'm going to do is I'm going to start by using an offset on the bottom, and that's to push it down into the ground, because I know that we've got this flat mesh at the bottom. So I'm going to put -20 on both of the min and minus offsets. And I'm just going to push the mesh down into the ground so it hides the disconnect with the roots. Okay, so that's the location. Next up is rotation. With rotation, I don't want to add to the rotation. I'm going to set the absolute rotation. And for this, I'm going to make it so it is -10 on Y to 10. So the angle they're at is a bit varied. And I'm going to make the Z rotation up to 360. So this means that the tree can be rotated. So that means they're not all sitting on exactly the same axis, so they all look exactly the same. Now, next we have scale. So I'm going to change this to be, I'm going to go 0.7 on each of the axes to 0.13. It's a bit larger than what we have in the notes, but I want to see if that looks more prominent. Now, with the scale, I want with the rotations absolute scale, I think is fine, not being absolute. Okay, now I'm going to plug the transform points into the static mesh spawner. Now, what you notice is this has not killed the previous wire. And this would be a problem because if I now look at the thing, we have a double tree on every tree. Well, on every point, we've got a double up. So what I'm going to do is I have to break this line. And I can hold down Alt and left click on it. And that will get rid of that line. Now if we look, our forest is looking slightly better. We got some trees that are shorter, some trees that are bigger. And because they're all rotated to a different angle, they look a lot more natural.
Yeah, I wonder if you could maybe dock the PCG on the bottom and show what each setting is doing. Oh, that might be cool.
That's a good idea. So just try.
Yeah, PCG, you really need to have two screens.
Yeah, it's quite hard to where is so here's my PCG. I'm gonna get it's got a slight overlap. But yeah, so does that look all right?
Yeah, that's perfect.
Try and squeeze that. Okay, so we have so this is what we've gone for. Again, the transform points. This is the big bit that I've changed. So I've moved them down a bit so we don't get oddities with the roots. I've rotated 360 on so it's going to give it a random rotation. And I've made the maximum and minimum scale quite different so that we've got so that they look more natural. Okay. Did people seem okay to continue?
Yeah, I think we're good.
Okay, let's carry on then. Now, okay, so next up, I want to add some rocks into the scene. Now, I'm going to do this in roughly the same way that I'm going to do our previous one. So I'm going to select all of these, Control C, and then press Control V. So I'm copying and pasting the landscape data, and I'm going to plug that in. I'm also going to put a comment on the bottom that says trees and bushes. I'm not finished with this, but it should allow me. It should allow us to see what we're doing a bit more. And I'll make them green. There you go. So what I've done is I've copied and pasted them, and I've created a new section. I'm going to call these rocks. Now I'll put a comment on them in a minute once we've made. Actually, I can put a comment on them now. So I'll drag off, put a comment, and I'm going to call it rocks. Now, for the rocks, let me see what settings I put on the rocks. I'm going to select the surface sample. Now, and I'm going to put a debug so that we can see them. Now, rocks are going to be bigger and they're going to be all over the shop. So the first thing that I'm going to do is I'm going to reduce the points per squared meter. I'm going to drag into here and I'm going to change this to 0.1. So we've got less rocks. Then what I'm going to do on the transform points. So again, first surface sampler, I've reduced this down so that we're getting less rocks appearing. Okay. Actually, you know what? I'm going to just hide my trees for a second. Ah, yeah, that's because I'm going to disable that as well. Okay, so the surface sampler I've done, and I've now got rocks that look like, got locations of rocks that look like that. Now the transform points, I'm going to change this because the first thing I'm going to do is, so I'm going for rocks that are sticking out the ground. So imagine big stones as you walk through a forest. So the first thing I'm going to do is I am going to drop them between -100 and -200. So we're automatically going to move them down. Now, the next thing I'm going to do is my rocks are the rocks I've selected don't have holes in them. They're complete models. So what I'm going to do is I'm going to change the rotation to be completely random. So if I was to turn back on, enable my trees, you can now see they're all sticking in random ones. So with the rotation, it's absolute, and I'm going to go 360 to 360. Next up, what I'm going to do is I'm going to change the minimum and maximum to be between 0 and 15. So our trees that we have in there at the moment are looking crazy at this point, but we'll fix that in a minute. So, and now we can see this on our points. So if I disable the surface sampler here, add the surface sampler in here, we now get something that looks like this, which is a big mess of spheres. And if I was to go down, you'd see that they stick out underneath, and that's fine because rocks can stick through the floor. So let's now, I'm going to turn enable off on it. I'm going to turn debug off on this, go back to my static spawner, and let's change our meshes. So if I type in static, at the moment we have my tree and my bush. If I type in my rock, we've only got one. So I'm going to delete the second rock here. So I'll delete the second entry and we just got rocks. So that is what my rock selection looks like. Now that looks okay. That looks all right at this point. I'm going to enable my trees and we'll see what the forest looks like. Now, it's not ideal. The main problem that I have with these rocks is they are overlapping. You can see that we've got a rock that's down here, which is overlapping with that, which is overlapping with the tree. And if I can find an example, we've probably got trees which are growing out of rocks. Yeah, there you go. We've got a tree which is growing out of a rock. So this is a problem. we got a number of problems. The first thing is they're overlapping with themselves. The second thing is they're overlapping with everything else. So we want to clean this up. So, and to do that, the first thing is overlapping with themselves. So again, I'm going to disable the trees just so that we can see them. And in order to fix this, I'm going to move my static mesh spawner over to the right. I'm going to hold down Alt to get rid of that line. And I'm going to drag out, and I'm going to type in self-pruning. Now, most of our rocks disappear. Now, self-pruning, this isn't working. And this is not working for a number of different reasons, but I'll show you some of the settings we've got here for. So with self-pruning, we have before pruning that looks a little bit like this. And if we do large to smaller pruning, we get something that would look like this, or small to larger pruning would get something that looks like this. Okay, the radius similarity factor. So that works fine. We've got new options here. Now that's not enough rocks. So the first thing is I could change this. I think I'll change it from large to small. So we're already on large to small. Small to large, large to small. Okay, so this has not worked. And this has not worked for a good reason. I can demonstrate this by looking at, if I turn on the debug on these transform points. Now, actually, if I turn the debug on the self-pruning is probably better. If we look at this, our cubes are considerably larger than our actual meshes. So it's hard to demonstrate. I might be able to get to it in wireframe. Yeah, you can see there, and wireframe is quite a good way of visualizing it. The bounds of the points which it is using for the pruning is nowhere near the same size as the rocks that we have placed into them. So we need to fix this. And so yeah, wireframe works really well for this. Now, in order to fix this, I think it's point extents, isn't it? So let's try it and change the point extent size in here. So if I change this to 30 to 30 to 30, suddenly see we're not far off now. So if I change that to, I'm going to get rid of I'm going to disable the transforming points. And I'm going to zoom in on one of these so that I can match up as closely as I can. Let's slow down my mouse movement. Okay, so I'm going to change, let's try 50. Let's say 50. I'm going to try 40. Okay, 50, 40, and on the X-Zone, I'm going to go for 40 as well. Now I'll go for 50. You actually need to, it's not ideal because what I would do is I would move that down slightly.
There is a bounds modifier node which will do this for you as well.
Okay.
And that will allow you to scale it down as well.
Let's do that then. Right. So I'm gonna. Well, no, I think that's close enough for our services. We'll move on with it. But you can now see that our bounds match the cubes a lot a lot better. So, and a little bit of overlapping, I'm not too worried about. So on the surface sampler, if you can change the points extents to 50, 40, 45, we also have a bounds modifier, but we're not going to touch that this time. You should find that our bounds are a lot closer to our rocks. So again, that's the sampler surfacer. We have 50, 40, 45. I like wireframe. It really makes it stand out a lot more. But as long as you understand that the points extent, you ideally want to match your you ideally want them to match your meshes, at least relatively closely. Okay, now I am going to re-enable the transform points. It's not great, but it is better. And I'm going to jump back into lit. I'm going to turn off the debug on these. I could try small to large. Okay, so I'm happier. I think that's enough rocks for me. None of them overlap on the points, and I'm fairly happy with that. Okay, now I'm turning back on the trees. Now, we still have some of the stuff is sticking out of the side of our rocks. So let's see if we can fix that. Now we can do this by, I'm going to drag this to the right and drag the spawn mesh to the right here. I'm going to hold down Alt. I'm going to drag off and I'm going to find a node called difference. Yeah, so I'm delete both of those. So when I'm working with difference, it is going to add anything that I've got into this difference node. It's going to use it to eliminate the nodes that we've got. So if I get the output of the self pruning and put it into the difference, so if I enable or disable, you can see that we're going to remove things that overlap with the bounding of the rocks. So again, you can see how important the bounds are to be close to the actual rocks themselves. Okay, so that should fix the overlap with the rocks.
I think you might also need to set the density function on that difference node to binary.
Yes.
Yeah.
Thank you. That's the thing I always miss.
Yeah, same.
So also on the density function, set it to binary. So now I'm pressing. So you can see that this is eliminating trees which are within the bounding box of the rocks. If I get time at the end, I might play around with changing the bounding box. Can you? We've got a difference in extents here. Can we use the mesh collision at any point?
Yeah, maybe. Those self-pruning attributes seem to be new because I don't remember them having any settings here.
Isn't it? Anyway, yeah. Okay, so we've got our trees and we've got our bushes. Is anyone seemingly having any problems or anything? We're about halfway through and we're making good time. So
Yeah, pretty smooth. No big questions.
okay. Right. Well, that brings me to a natural stopping point for a break. We're going to do grass and we're going to do a path after this, and then look at some examples. Right. We have created our our forest so far, but we have very little on the ground. So let's add some grass. So I'm going to come down to my landscape data. I'm going to move this down a little bit more. And I'm going to drag off and do a surface sample. And this time I want a lot of stuff because we're making grass. So I want to surface sample a lot. So I'm going to put a debug on and I'm going to make this 10. So that's 10 points per square meter. Now the looseness I'm going to put to 1.2. And I'm going to reduce the point extents. I'm going to go the point extents to 10 each. So you can now see that we have a lot of nodes. Now, in order to demonstrate this, I'm just going to hide the static meshes of the other two. So I'm going to push disable in here. And we can now see that we have scattered points all over the space. Now, I don't want to scatter. I don't want to put grass when it is too steep. So as you can see with our landscape texture, as soon as it gets to a specific angle, we get mud, and on the floor we get grass. So I would like to make this conform to a similar logic. So what I'm going to try and do is I'm going to try and get rid of these at a certain value. So in order to do that, I'm going to use the density node, and we're yet to use the density node, so it's very exciting. I'm going to come down to the surface sampler, and I'm going to drag off, and I'm going to type in normal to density. So as we've talked about density before, but at this point, we are taking the normal value and we are adding it and we are plugging it into the density. So if I was to, I'm going to turn off the debug on that, turn on the debug in here, you can see that we get a whole load of white. It all looks white now. Now, it's not actually white. These are actually a slightly grayer than the ones that are down here. But this will give me how close it is to pointing directly up. So this is a great quick way that I can filter. So now that I've got the value into density, I'm going to drag off and I'm going to go density filter. Now on my density filter, I've got the lower bounding to the upper bound. Now, because this is very, very low, I'm going to make the upper bound 0.95. And then I am going to turn off the debug on that, on the debug here. And you can see now only ones that are looking directly down will have grass on them. So I could play around with that. I could play around with the value. Like if I was to make it 90, we'd see that you get a little bit more. But I think 95 is a good starting point. So this is an example of us dragging a value, getting a value into density so that we can start using it for other means, and we can visualize it, which is quite important. I could remap the density is something I can do as well. just so that I can see it. Because if I needed to see it, if I start with the outrange being 0.8 and I turned off 1-to-1 outrange. It's weird. I would have thought that would show up in the color. Oh no, that's because I got this around the wrong way. That should be. There you go. So that you can see, I can now see quite clearly that these are in black. So the remapping the density is quite useful so that you can get it to be very, very specific. But the density filter will work fine. Okay, next up, we need our static mesh spawner. So I'm going to drag off with this and go static mesh spawner. And within the mesh entities, we are going to need 5. 1, 2, 3, 4, 5. And again, I'm going to type in static at the top. I'm just going to drag this up because that will allow us to see. So we can see, this gives us a quicker way that we can see the meshes. So in this case, I want to change this to, we've got flowers and we have grass. So I'm going to say my flower. It's going to be 1. I'm going to type my flower 2. And then we've got grass. So I'm going to go I'll just select my grass 1, my grass 2, and my grass 3. So we have all of the different nodes here. So again, we've got 2 flowers and 3 grass. So I'll save and force regen. And now we can see what this looks like. Now this to me is too much flowers. So I am going to change the weighting. So if I type in weight or WEI, you can now see what the weights are. So how weights will work is they will add up all of these values, and then that will give you a percentageal, divide by the total, and that'll give you a percentageal. So what I'm going to do is make sure the grass is about 8 times more than well, not 88, 8 times more than the flowers. Yeah, I like that a lot more. Now, we could also add in a difference filter again, if you want to. I'm gonna add one in. So I'm gonna hold down Alt here and type in difference, connect that up. I'm going to set the difference to binary. And from the difference, I'm going to plug in both of the self-pruning and the transform points. Then I'm going to turn these 2 back on. You know what, I'm going to get rid of the rocks, I think, because my bounding box is so big for the rocks that we don't get any trees around it. But you can see, so now we're just you should be able to see we've got a relatively nice sort of forest. Let me just wander through. Not really a forest, is it? It's more of a, it's not quite a meadow, but a woods. Okay, so is anyone having problems getting to that? Because this is where we're going to be adding in a path. Are we good, or is there any problems?
There are a few people typing.
So this was the last piece of code that I wrote.
Someone's asking if the meshes that get spawned are instant static meshes or just regular static meshes.
Well, they can. These at the moment are regular static meshes. You can spawn actors, which I'll demonstrate later, and actors can have anything in them. However, they have their own problems. Skeletal meshes, I don't think you can, unless it's within an actor. Was that the question, or?
Oh no, just so like in the static mesh spawner settings, I guess you can change what kind of static mesh you spawn, whether it's an instant static mesh or
Well,
a
everything
regular.
is instanced. That's
Yeah.
one of the great optimization of PCG. Unless you do something non-default, everything is going to be an instanced static mesh. It's like if you use the foliage system will automatically instance any of the meshes that you're working. So it's really quite good from an optimization point of view.
The one thing I
Yes.
will add to that is like the static mesh spawner by default, like the default settings that you actually get in the static mesh, like in the entries are quite unoptimized. I guess like the mobility by default is set to movable, I think,
Ah, right. Okay. So
and things like that.
that's interesting. So if I go into the rocks, um, and I look at the mesh entry, the descriptor, the mobility is set to movable. So that could be static, quite easily.
Yeah. Especially when you have a lot of animated foliage, for example. There's also like a world position offset disable distance in there, I think. You might have to type it in because there's so many settings.
Yeah, world position offset, disabling a distance is brilliant because nanite gets a lot more expensive as soon as you turn on world position offset, and even if you don't move anything, well, actually, yeah. So yeah, so there are a bunch of settings in here. It would be instanced, but you might still want to play around with the settings to make it as optimized as possible. But
Someone's asking to see one of the surface samplers. I'm assuming the grass one, just to see what settings you have.
yeah, so the surface sampler, I've changed the points to be only 10, looseness to 1.2, and the points per square meter to be 10. Right, do you think I'm good to continue?
And there's one more person typing. I should see if it's related. Yeah, so we might cover this later, but can we have the PCG volume not be a cube?
I wasn't actually going to cover that later. I'm
Okay.
okay with it not being a cube. Lucas, do you want to, have you ever done it with a non-cube?
I mean, you could do splines, right? And
Yeah,
just sample the inside, and then you can have a custom shape that way.
Yeah, splines. Oh, so we play a little bit around with splines, but yeah, it's you can use splines. I'll show you how to use them, but I use them as an excluder in most cases.
Yeah.
But it would be interesting to do. So I'll show you what I'm doing with the splines. Or Andrew, I don't know. The way I'm doing it, I've got a theory isn't the right way, but I'll run it with everybody, and then you can tell me afterwards if you do it differently. So next up, I'm going to move the PCG volume over to the right now, and I'm going to bring up the content drawer because for the next element I'd like to do, again in exercise, you'll find that we have something called BP My Path. And what this is I'll open it up and show you guys. It is a actor. Oops. Where did my view go? Sort of window. Oh, okay. So, it is a actor with a spline on it. And this spline has a simple mesh, which has a kind of ground-esque ground texture on it. Now, the path, oh, I don't want that one. The path is a little bit interesting because we're using a runtime virtual texture in this, where we're drawing it to a runtime virtual texture. And what a runtime virtual texture does is it allows you to draw to a texture, and then other materials can read from that texture and can inform how the material looks. So in this case, this node tells it to draw to the texture. And in the landscape, we have an equivalent node, which I'll show. So material. So in my landscape material, I'm getting data from the virtual texture. So I'll demonstrate this as I go along. Virtual textures are really useful. This is, I think we used in texture baking in, no, we didn't. We used just baking. But this is the render target that we are saving the data to. We are then drawing from it inside the landscape, and we are blending the attributes between the landscape and the landscape material and the path material. So with that explained, let's add this to the world. So if you get your path and drag it into the world, you should get something that looks like this. Now, splines are fiddly to work with. Now, if you can see on the spline, first thing is we have the whole actor, and with the whole actor, I can rotate it. However, if I can select any of the little buttons here on this spline, I'm going to get some different elements up. This is going to allow me to change it. So, for example, I am, if I move this, it will move the spline. So I'm changing the points of a spline. Now, I'm going to move this over here because I want to draw a path through. Now, the easiest way I usually find of doing this is if you hold down, if you get the end point of a spine, and then if you hold down Alt, drag out, you can make another point. And what I would like you to do is create a path that runs through the PCG volume. And try and keep it above the landscape. Now, the other thing you can do is if you want, you can right-hand click on it and go add spline point here. So you can add an extra spline point in. So there's numerous elements that you can do. But the main thing is you can also grab the tangents and you can change the rotation, but the tangents generally not that useful. But if you have a point selected, the easiest thing to do for me is to just grab a point, hold down Alt, and I can drag out and that will give me a spline. So with that, I can draw my path through the world. So that is my creation of a path. Now, I understand that that is, if you're not used to playing with paths, that's not particularly an easy thing to do. So I'll give everyone a second there so that they can fiddle around with it. I'm imagining in chat there's just a lot of screaming. It's like, good. But yeah, it's the selecting of the points, which is yeah. If Andrew and Lucas, if you can tell me when you think it's good to continue, you've got sort of a
think you're probably good. This has been a pretty quiet one in terms of the chat, so I think people are taking it in pretty well.
okay. All right, so might just be me that's had trouble with that. Okay, so now this path doesn't look very good. What we really want to do is we want to draw it to the texture below, and that's quite straightforward to do. So with the path selected, actually I'm gonna okay, with the path selected, what we want to do is we want to select a runtime texture. And as you can see, we have RT VT landscape. And as soon as you select that, you should notice that we now have a path on the floor. And as soon as you deselect the path, you should see that it disappears. And that is due to the way that I'd set up the runtime texture. Is that within the runtime virtual texture volume, you can see here, you can see that we can now got a path which is on our render target. I had selected, so we just come on to modify properties only, advanced, hide primitives. And what that will do is anything which is adding to the landscape, it's going to hide that primitive. So you don't need to worry about that too much, but it's a great way to be able to paint to a landscape texture. Now, what we really want to do is we want to use this inside our PCG. So I'm going to close these down. Say these down. I'm going to drag back in my PCG. And at the moment, we have grass growing on our path. And that we
Ed,
do.
real quick,
Oh.
if you don't mind just going over that step again, there's a couple people that missed the runtime virtual texture.
On the runtime. Okay, so I'll go over this. I think it's really useful to understand. But it's already built in this project. But okay, so we have something that's called a runtime. Actually, you know what? I'll put one together. So I'll duplicate this rock. Okay, so we have something that's called a runtime. Actually, let's find something funner. What about tree? I'm going to. I'll just find how many. It's got too many. Let's find a chair. I must have something in here that called a chair. Okay, that's just one texture. So I'm going to drag that and put that into my exercise. And I'll move that here along with material chair. Move here. Okay, so let me talk through what a runtime virtual texture is. Let's start off with, on our landscape, we have a material. Okay, and if we look at our material, I'm just going to open this up. So our material has our standard landscape material here. So what this does is this this is going to blend. We're just blending between mud and grass in this case. So we've got just a color. So this is creating the effect where on a gradient we get mud, and on the floor we get green. So I'm just very, very basic material. However, here we have a blend attributes. And what this is doing is this, we have a runtime virtual texture sample. And we're using this sample in order to blend in to the, to blend two materials in. And now what happens is, now I've created a path. The material on this path has an output node. So let me just find the, so on my path, I have a material, it's actually the other one. And this material has an output for a runtime virtual texture object. And what this does is, if I grab this and so I'm writing to a runtime virtual texture, and I am inputting into, and I'm drawing from that value in the landscape material. Now, in order for this to work, we need a volume, which is called a runtime virtual texture volume. And this has a render target. If you look at this render target, so if you look at the image on it, you can see there's a brown line. And that's because that brown line is this path that I've added via a spline. So it's projecting down through the render target, and it is saving to this texture. Then my material is cooling from that texture. And if I wanted to demonstrate this, I'll demonstrate this on this chair. So on this chair, I am going to grab the material. I'll duplicate this material, and I will place that inside of the exercise. So if I open up this material, this is my chair material. Okay, not terribly complicated. Now, if I made a node for output, runtime virtual texture output. Now, if I plug the base color into that, the metallic, we don't have a metallic. We do have a roughness and a normal. And I need to make sure the mask is set to 1. Now that means that anything that has this material on it can write to a runtime virtual texture. So if I go back to my level, I'll place my chair into the world. I'm going to scale it up. So We've got a large chair. I'm going to place this material on the chair. Now, that should be within the runtime virtual texture. If I then change the, if I then say draw in a virtual texture, and I select the virtual texture, it's weird. Why isn't that? That should work, shouldn't it? What am I doing wrong? Can you spot anything I'm doing wrong, guys?
Oh, no, seems right.
Let me double check the path and see what settings I have on there. So, only modified, no collision, plane, rendering, override material. Is there any settings in here? Use a spline mesh. Okay, that's really weird because what this should now do is this chair should write to that runtime virtual texture, but clearly I've not ticked on something. Let me look at the settings we have here. Sorry, I'm just checking my settings. Default virtual texture. Drawing virtual texture, that looks correct. It's within the virtual texture. Yeah, I did something wrong. So that should now draw to that virtual texture. But I mean, I'll look it up at the end before the next session. But and I'll try and demonstrate that. But what this effectively should do now is that should be projected down onto the landscape. During main pass. But I'll have to look up what I've done wrong. I've got some notes on it. But yeah, so I will demonstrate that, but it allows you to project meshes into a virtual texture. And it's a great sort of way of making a 3D object into a decal or something. But it also sort of it can be an optimization trick as well for to do stuff. Okay, so sorry, let's get on with stuff, and I'll try and demonstrate the chair trick a bit later on. Oh, that's going to annoy me. Okay, so let's go again. Let's use the PCG in order to cut this out. So find the PCG, it's over here. So sorry, back to the PCG. We have the flower and grass. Now what I need to do is I need to get this, I need to get the details of this spline into the PCG so I can use it. So what I'm going to do is I'm going to type in spline. We got an option for a spline sampler. No, first we have to start with the get spline data. Okay, and then we will sample it. But it needs to know how to find the spline. And now we can see by default we have self. And the reason we have self is because PCG can be used as a component on an actor. And if you're doing it that way, it can find all of the splines which are part of the actor itself. However, in this instance, we're not making it as a component for an actor. So self isn't going to work. So in this case, what I'm going to do is I'm going to drop down and I'm going to select all world actors. Now, in order to reduce it down, I'm going to do the actor selection by tag. And for this, I'm going to type in path spline. Now, the reason we do that is because I've already added the tag to this actor, so it should find this. So we're going all world actors, path spline. You can also have select multiple. So this is what I'm doing. So it's path spline. We have to get that spelling exactly right because it's going to be looking it up. And it's going to do a match on that. Okay. So, okay, so we've got the spline data. So the next thing is we want to sample this spline. Now, the way I usually set this up is on the dimension, we are going to select distance. Actually, we do not have distance anymore. Lucas, what's it been changed to?
I've got distance.
Oh, yes.
It's on the
yes,
mode. Yeah.
Sorry. Wrong node. I'm looking at the wrong one. Yeah, they swapped them around. You see in the notes, it used to be mode, then dimension. Now it's dimension, now mode. Okay, so what I'm going to do is I'm going to create a point every 50 centimeters down this spline. Then I am going to transform these. So transform points again. I'm going to debug at this point so that we can see it. But the main thing I'm going to do on the transform points is I'm going to change the scale. And I want this to be an absolute scale. And I will untick the lock boxes because they're going to force it to keep the same aspect ratio, the ratio, so scale ratio. So I'm going to change this to 200. 200, 100, 100, and I'm going to go 1.5 to 1.5. Okay. And that is absolute scale. I'm turning off uniform scale. And once you made that absolute scale and you've turned off uniform scale, you should see something that looks like this. Now, I'm actually going to come in and I am going to make the minimum max 800 because I want it to intercept with the ground. So what we've effectively done now is that gives us, so hopefully you've got something that looks a bit like this, but that gives us a cutter. And at this point, we can plug this into the difference nodes. So I'm just going to plug that into both of the difference nodes that we've got. I'm going to turn off debug. And what you should see after you've done that You could even do it with the rocks, because I don't think I've got a difference node on the rocks at the moment. We now have a path where nothing apart from rocks get in the way of it. So again, the transform point, it's a little bit tricky, but it's the scale, which is the big thing here. We want the scale minimum to be we need to untick uniform scale, and we need to tick absolute scale, and it's 1.5, 100, 800. And you also have to untick the locks. Now, Andrew, Lucas, is that how you would do this?
I mean, it's a good way of doing it. And I guess the most simpler way, instead of going through the virtual texture, you might just paint the actual path using the paint tools and then just filter out the landscape material layer. That's how I've been doing it quite often.
All right. Okay, that's interesting. I'd have to add that in. Maybe we might be able to demonstrate that in the lab.
Yeah.
Yeah. So I'm using the spline in order to create a cutter. Okay, now I'll throw up how this should be interconnected. But apart from that, that is sort of the end of our the end of our lesson. I've got a couple of examples that I'm going to show you. But is anyone majorly stuck? We got the lab afterwards, so we can jump in. But this is roughly how it should look. Okay, if there's not much noise, I will jump onto the examples. Okay, in that case, I'm going to jump out of this. I'll plug this at the top in case we need it. And let's have a look at some of the examples. There's only a couple here. But yeah, so hopefully you have this working now. So next up, I wanted to show an example of vines. And the reason I kind of like vines is because what we're doing is we're going in the opposite direction. At the moment, everything we've done is we have scattered stuff on the ground. Where in this case, and I'll throw this open to TAs as well. What I've done in this case is I've scattered vines on meshes. And this is an example of using the geometry scripting, I believe. I'm scattering them on the meshes and allowing them to hang down. Now, if I open up what I'm doing here, I am using a different method of scattering. I'm using something that's called a world ray hit query. So I am doing 2 ray casts in slightly different upwards directions. And then I'm only registering meshes which have vines tagged on them. So in this case, if I come in here and I look at the tags, I remove this tag from this one and refresh my force regen, you'll see there is now no vines on this one because I've removed that gameplay tag. So it's no longer sort of creating them. So what it's doing is it's firing raycasts up, and when it hits one of these, it's adding it to the sample so that I can then use it as a transforming point. So it's an example of just adding to meshes. Lucas or Andrew, would you do this differently? What was sort of would be your approach?
That's great. Because in other ways, you could do like a mesh sampler and then using the normal direction, mask out points that are -1 in the Z, I guess. but this is great as well.
Fantastic. Okay. Now my final example is, you might need to refresh this. I'll try and refresh the entire thing actually. So just find. So I'm going to do a generate just to force a, so we'll clean up and generate just to force a regeneration. And this takes a while. But what I'm doing in this instance is generating a city. And this is done in a couple of different ways. So it is, I'm actually not using PCG a whole lot because these buildings are all actors. And this is kind of the old school way of, like, before PCG came out, I created this script that basically allows you to create buildings randomly by denoting the size of them. Now this works very well, and it also does car parks and stuff. But if I was to do it now, I would write it with PCG because this PCG is a lot more efficient way of creating something like this. But the reason I'm demonstrating this is, firstly, by turning off the looseness, I've managed to put it in a grid type shape so that we can create city blocks. And I am not scattering meshes. I am scattering actors. And these actors have construction script on them. So the actors will go away and randomly change the settings to make a building so that these are all completely randomized buildings. So this is just a demonstration of how, rather than using a static mesh that we've done up to this point, we can actually use actors. I'll try and find the PCG settings, instance, double click on that. And so this is the simplest PCG you get. It's got a surface sampler, but the looseness is at 0 and the size is large. And then we're spawning an actor. And this is the gray building actor. And all of the work is actually done in this actor. But this actor itself could have a PCG on it that would trigger. So I could, if I was to recreate it, I'll create a PCG on an actor. So it spawns actors, which on construction do the building. So if I was to grab this gray, no, so yeah, no, I won't go over. Yeah, actually, well, there you go. So this is, if I open up this actor, you can see that I've done all of this programmatically. So I'm creating a construction, I'm just defining the values here, randomizing between the templates, between a parking lot gray building and yellow building. I'm building it out like that. So these are just two examples that were sort of just showing how I can, different ways that you can use a PCG. Okay, so thank you, everyone. I hope that works for everyone. I will see you in the lab.